AI is getting so powerful, it's almost scary. But what if the next giant leap forward isn't just about being smarter? What if it's about being way faster and more efficient? Today, we're going to dig into a brand new model from Metafair called VLJPA, and trust me, it proposes a pretty radical new way for AI to understand our world. So here's the game plan. First up, we'll tackle the big efficiency problem that's holding back a lot of today's AI. Then we'll get into the secret sauce, how VLJPA predicts meaning, not just words. After that, we'll pop the hood and see how it works, check out the, honestly, pretty mind-blowing results, and wrap up with what this all means for the future of AI. Ready? Let's do it. All right, let's jump right in. Section 1. To really get why VLJPA is such a big deal, you first have to understand the massive challenge it's built to solve. So here's the thing. You've probably felt this yourself, right? You're waiting for an AI to respond, and you're thinking, why, with all this incredible power, does it feel so sluggish? This is especially true for real-time stuff, like trying to get an AI to understand a live video feed. What's the holdup? Well, the answer is all about how they think. See, most of these models generate text auto-regressively. Fancy word, but it just means they predict one word or token at a time. It's this super meticulous process of guessing the next word based on everything that came before. It's powerful, for sure, but man, is it demanding. It's a huge bottleneck for any real-world, real-time application. Okay, I love this analogy. It makes it so clear. Think of it like this. The old way is kind of like a court stenographer. Their job is to capture every single word perfectly, super detailed, right? But it's also slow and takes a ton of energy. Now, the new way, the JEPA way, is more like an expert analyst. They're not writing down every word. They listen, and they instantly get the core summary, the meaning. It's just faster, way more efficient, and it gets straight to the point. That stenographer versus analyst idea, it perfectly captures this massive shift in thinking. So let's dive into how VLJPA actually builds this totally different approach to understanding things. So get this, instead of trying to predict the exact next word in a sentence, VLJPA predicts the idea, the abstract meaning of the next concept. It works by predicting something called embeddings, which are really just a fancy way of saying mathematical representations of meaning. And this is a huge change. It's the difference between trying to guess the specific word dark versus just guessing the general concept of the lights are turning off. And all of this magic happens inside what scientists call an embedding space. The best way to picture it is like a giant invisible map of ideas. On this map, concepts that mean similar things, like lamp off and room is dark, are clustered really close together. This makes it so much easier to predict the next idea because you just have to land in the right neighborhood instead of hitting the exact address of a specific word. And hey, don't just take my word for it. The researchers themselves say the model is freed from the heavy burden of getting every single word right. All it needs to do is predict the abstract representation, just get close to the right idea on that map of meaning. And that shift, from the surface level of words to the deeper level of meaning, is the whole secret to its efficiency. Okay, so how does this thing actually work? What's going on under the hood? Let's take a peek inside the architecture. The Joint Embedding Predictive Architecture, or JPA. Now, I know this diagram looks a little intimidating, but the core idea is actually pretty simple. You've got an encoder on the left that's looking at the visuals, like a video. On the right, another encoder is figuring out the meaning of the target text answer. But the real star of the show is that predictor in the middle. Its one and only job is to learn how to make its guess about the text's meaning match the actual meaning. It's just constantly trying to close that gap between its prediction and the reality. So, predicting meaning instead of words, that's key number one for efficiency. But that's only half the story. The second key is this really clever trick they came up with called selective decoding. And this is all about deciding when the AI should bother to speak at all. Okay, check this out. Because VLJPA is always thinking in this abstract meaning space, it can watch a live video and just generate this continuous stream of meaning, like a river of concepts. It doesn't have to constantly stop and translate every little thing into words. It just watches the stream. And only when it detects a significant change in meaning, like, whoa, something new is happening, only then does it bother to fire up a lightweight little decoder to spit out some text. It's so smart. And you know what's really beautiful about this? This single unified architecture is a total Swiss Army knife. I mean, look over on the right side of this diagram. It can handle text generation, visual Q&A, classification, even text-to-video retrieval, all without needing a major overhaul for each task. It's incredibly elegant. Okay. The theory sounds amazing, right? But does it actually hold up in the real world? Let's get to the good stuff. Let's look at the hard data. So, the researchers put it to the test. A head-to-head battle, VL-JEPA versus a traditional word-by-word model. And the results? They're not subtle. Just look at that blue line. That's our guy, VL-JEPA. It learns way faster and just rockets up to a higher performance level on both captioning and classification. It totally leaves the old model in the dust. And get this, it does all that while being way more lightweight. We're talking 50% fewer trainable parameters than the traditional model it was up against. Stronger performance with half the muscle. That's efficiency. And that selective decoding trick we talked about? Oh yeah, it works. In their tests, it cut down the number of expensive decoding operations by nearly 3 times, a 2.85x reduction without losing any performance. That is a massive computational saving. But wait, it gets even better. They threw it into a zero-shot setting, which basically means testing it on stuff it had never been specifically trained for. And even then, VL-JPA outperformed heavy hitters like Clip and Siglip 2 across 16 different video benchmarks. So it's not just efficient, it's also incredibly adaptable and smart right out of the box. All right, so what does all this mean? A faster, leaner, smarter AI sounds cool, but what does it mean for us in the real world? Let's connect these technical breakthroughs to the future they could actually build. While this level of efficiency really kicks the door open for things that just seemed like science fiction before. I mean, think about it. Smart glasses that can actually understand what you're seeing in real time and give you helpful advice. Robots that can react to their surroundings in a much more natural, fluid way. We're talking live action tracking for sports, real-time scene recognition for security, AI-powered planning. All of these things suddenly become a lot more possible. When you boil it all down, the big takeaway is really this. Maybe we've been going about this the hard way. There might be a much more efficient path to creating truly intelligent AI, and that path is about moving beyond the nitty-gritty of predicting word by word, and instead focusing on the more intuitive task of predicting the essence of meaning. If you do that, AI can learn faster and run with so much less computational baggage. And that leaves us with a really fascinating question to chew on. We've spent decades trying to teach machines our human language word by word. But what if they can develop a deeper, more efficient understanding of the world without being tied to words? What other human limitations could they move past? What's the next frontier for an intelligence that thinks in pure, unadulterated meaning?